Well. Hello everyone and welcome into Yena livestream. And today we'll be doing... It's a Torture Tuesday, let's do some quantum mechanics. Hello everyone, how are you all doing? How are all of your days going? Is my chat broken? No it isn't, okay, just know that. Well, hi there everyone, how are you all doing? Tell me, how's life? How's the weather? How is stuff? Let me play some music in the background. Soda Casey 2023 music. Be precise. It's still a bit loud. There we go. Is my chat broken? Is there no there? I want to make sure that my chart isn't broken before we go on, because that would be quite a problem. Oh, hi there, Alex. Okay, it isn't. Thank you, Alex. Alright, cool. So welcome to Torture Tuesdays, a series of live streams during which I'll torture myself. Like today with quantum mechanics. It's gonna be fun. For today, this is from the previous live stream, by the way. For today, what I would like to do is, I would really love to get through light. All of light. Hi, look, hi, please, hi there, everyone. Hi, welcome. I would love to get through light, like the photoelectric effect, quantum theory of light, classical interference of light waves, and quantum interference of light. If I could get through these four, then I would count this live stream as a success. The problem is, this is gonna be pretty difficult. Even by the science live stream standards, so... Ooh, I suppose let's get into it. First, let's revise things quickly. So, I'm pretty certain we finished round... Yeah. I'm pretty certain this is the moment where I got confused. Velocity line vacuum equations. So we have this equation, cool. Know that EY depends on the combination x minus ct. It follows that the wave maxima and minima satisfy x minus ct equals constant. Thus the wave maxima and minima propagate in the x direction at the fixed velocity. So this one just proves that the speed of light is constant. Cool. An expression such as the equation determines the wave angular frequency as a function of the wave number is generally termed a dispersion relation. Ah, fudge. Okay. So equation 245, so this one, right? 245, so this one. This is the equation, yeah. So expression such as equation, such as this equation, determines the wave angular frequency, because this is angular frequency, correct? omega angular frequency, yeah, okay, we're getting there. As a function of the wave number is generally termed a dispersion relation. Okay, so we have angular frequency and a wave number. Now, I'm pretty certain angular frequency is just a wave number for time. So this is for position, this is for time. And they both... okay, yes, so... this is for the position, this is for time. And this basically tells us the relation of wavelength in time, if you will, to wavelength in position. Hi there everyone, hi Tom, welcome. Okay, cool. It's effectively saying, so right here, dispersion relation makes sense, relation between position and time, so that's why relation. As we have already seen, and as is apparent from the equation 246, so this one, this mess of a thing, the maxima and minima of a plane wave propagate at the characteristic velocity. So the velocity is just equal to omega divided by k. Wait, omega divided by k? Why omega divided by k? Oh, because they're both inverses. That's so dumb. So this is okay, this is pretty silly. If I'm understanding this correctly, then that is pretty silly, because what this is basically saying is, hold on, let me just show you just how silly that is. Oh, that's silly. What this basically is saying is, it's nu, I'm pretty certain, nu of p, of velocity. No, this has to be velocity because mu is different. Velocity, yeah, velocity p. So velocity of propagation, alright? So the speed velocity of propagation, I feel like we all get what the velocity is. So velocity of propagation is equal to omega, wait, fraction, omega divided by k. Now, what is omega equal to? Well, omega is equal to, well, inverse of wavelength, which means that this is equal to fraction 1 over lambda. Obviously, you have to, this is not 1, this is the initial, but doesn't matter, we don't care about that. And then k is equal to inverse of period. Did I do this right? No, the other way. This, and then right here we have inverse of the period. Which basically means that what we get from this is lambda. Not capital lambda, lowercase lambda. This is what we get. So omega is 2 pi, yeah, as I mentioned, this is, yeah, wait. 2 pi divided, yes, wait, omega? K in this case. K would be equal to 2 pi divided by, wait, no. Wavelength would be equal to 2 pi divided by k. No, don't worry. I mean, there is crazy lot of characters going on. In this equation alone, we have 1, 2, 3, 4, 5, 6 different characters, not numbers, alright? And we're only doing division. Only division. So that's insane. But what we end up with is lambda divided by t. And what this is, it's wavelength and period, or in other words, wavelength. So this is kind of like saying that this is wavelength of position divided by wavelength of time. This is kind of what we're saying. So position divided by time, it's like meters per second or miles per hour or feet per second, I guess. This is velocity. That makes sense. So, okay, so this is basically the velocity version of waves. This is something we can call kind of velocity of waves. Makes sense. Okay, cool. It's really confusing because right here we basically have time divided by position, but that's only because both of them are inverses. So it's just, people make it, yeah, it's more confusing than I don't like. I don't know. It's just really confusing. You have time divided by position in theory, but in practice both of these are inverses, which basically means that you end up with this. So yeah. Cool, great, fun. Which is known as a phase velocity. Okay, so it's actually phase velocity, not propagation. So kind of velocity of waves, phase velocity. Which makes sense because, well, it's as if you're increasing a phase. Hence, the dispersion relation is effectively saying that the phase velocity of a plane light wave propagating through a vacuum always takes a fixed value c, irrespective of its wavelength or frequency. That's, yeah, so speed of light is always constant. From standard electromagnetic theory, the energy density, the energy per unit of volume of a plane light wave is this, where, okay, this is a constant, is equal to whatever. Phase velocity isn't, phase velocity is the velocity with which the peaks of wave move. There's another one, but I'm sure it comes up later. Yeah, so as I mentioned, kind of velocity for waves. Furthermore, a light wave possesses linear momentum, as well as energy. The momentum is directed along the wave's... Okay, this is actually really interesting. A light wave possesses linear momentum, as well as energy. The momentum is directed along the wave's direction of propagation and is of density. This is such a quantum mechanical sentence. You have light with momentum. No, you need mass momentum. Just want to say your channel is an absolute gem. I hope you get 1 million subs. Yes, but thank you so much. It will probably take me years to get millions of subs because, or I mean 1 million subs because, apart from the addition to quantum mechanics video, my channel really didn't spike much recently. It's really average. But still, I appreciate you saying that, and I don't really need million subscribers. I'll still be making videos. I'm just glad that people enjoy them. The so-called photoelectric effect, by which polished metal surface and metallics will eliminate. Yep, the following facts I'm trying to kind of speed read. Oh, by the way, link to this entire textbook in the description in case anyone. We make thermophysics. Oh, maybe. I'm not a physicist. I should mention, I'm not a physicist. I just make physics because physics is a starting point for basically all of science. I'm a generalist. And so if I want to move on to chemistry, then I have to start with physics. So I will probably in the future make a video about all sorts of crazy things. Aerodynamics, thermophysics, dynamics in general, actually. Space travel physics, crazy law of partial derivatives. Yeah, but it will take me a bit. Can establish a bracket for observation physics given surface only emits electrons when the frequency of light which is a property of metal. Second, okay, that's second, the current of photoelectrons when it exists is proportional to the intensity of light falling on the surface. Third, the energy of photoelectrons is independent of the light intensity but varies linearly with the light frequency. These facts are inexplicable in the framework of classical physics. Cool. In 1905, Albert Einstein proposed a radical new theory of light in order to account for the photoelectric effect. According to this theory, light of fixed frequency nu consists of a collection of indivisible discrete packages called quanta, whose energy is... A light of fixed frequency nu consists of a collection of indivisible discrete packages called quanta, whose energy is... So energy would be dependent on the frequency. Makes sense. A physics test about the fission and fusion. Any tips you have to describe such a phenomena? Fission and fusion. A physics test. I thought for more on the chemistry. Alright, physics and fusion. I mean, I don't really have any tips. Depends on how much in depth are you going into fission and fusion. If it's okay, physics test. So is this entire test about this phenomena? Because then I can't help you. That requires specific knowledge, which I'll be honest, I'm just lacking. But in general, I don't describe such phenomena. Chain reaction. I don't know. Feels awkward. I'm not a physicist. Sorry, I don't know specifics. I'm not great at exact specifics. That's why I'm studying quantum mechanics to get better at these specifics. New constant, nature Planck's constant, yes. Oh wait, is this where Planck's constant comes from? Wait, is this where it comes from? That's actually... Oh, if it is, then that's actually really nice. Okay, but here they're talking about theory, so at the very end they could be like, Einstein was wrong, and yes. Oh, it is! Well then. I really wish I'd known that... Oh, well... I was wondering for quite a while why Planck's constant was a thing. It makes sense. I'm regretting quite a lot right now because I wrote a lot of things in my notes using the Planck's constant without ever understanding why that constant even exists. Okay. Because Max Planck was first introduced the concept of quantization of light. Account for the electron black body. Yeah, I suppose the electron of the surface line. I'm looking for math more than introducing. Didn't really want to accept that light is made of packages that Einstein said in. Want to accept that light is made of packages that Einstein said in 1905. It's actually true. Okay, so this theory is what we use today. Potential well. Okay, suppose that electrons at the surface of a metal lie in potential well of depth W. In other words, the electrons have to acquire an energy W in order to be emitted from the surface. Here W is generally called the work function of the surface and is property of a metal. Suppose that an electron absorbs a single quantum of light. Its energy therefore increases by h nu if h nu is greater than W, then the phenomenon then the electron is emitted from the surface with residual kinetic energy. Hi the HO, by the way. Hi. Okay. Hold on, I'm processing. This is certainly important. Should note this down as E is equal to H nu. Yes, that certainly is important. Hi the Smith too. Welcome to the live stream. If H nu, okay, so if the energy is greater than W and W is just work function of the surface, then the electron is emitted from the surface with residual kinetic energy. Okay, so for each kind of surface you have a W, and if the energy of the quanta of photon is... Wait, is quanta a photon? I know, the point is, okay, so if the energy of the quanta is higher than the W, so the... yes, okay, sick. I'm really glad, Alex, you're here, because I really need someone. It feels really nice to finally have someone in the chat to double check me and, you know... it really feels nice, because normally I make all sorts of wild claims. Quanta package, photon package of... Okay, cool, sick. Please make a video on thermophysics. You just teach so well. I will learn better from you. My just love from India. I'm really glad you like videos. The issue is, as I mentioned, I would just need a larger budget to make more videos. You have to remember, I make all of these suckers myself, and that's quite time consuming. Hi there, guy. Alright. So, this is cool. Basically means that for each surface of work function W, is emitted from residual kinetic energy. If H nu, so the Planck's constant and the inverse of the period, so the frequency, so the Planck's constant multiplied by frequency, or in other words, energy, is greater than W, then photons are emitted with residual kinetic energy equal to nu minus... This makes sense. Okay, this is actually unbelievably simple when you think about this. You have W, which you can think of as energy required, and then you have the energy of the photon. So the energy of the photon minus required energy would give us the rest of the energy, so the kinetic energy in this case. It makes sense that if there's less energy than is required, then they don't get emitted because they don't have enough energy. It makes sense. Electrons are emitted, not photons. See, that's why I need you. Electrons. That's what I mentioned about making wild claims. Electrons. Whoops. Electrons. Important distinction. You need more windows open. Oh, shut it, Deft. This is already Torture Tuesday. Don't drill me even more. Good morning. Your channel is good to trust the process. Thank you. I really appreciate you saying that. Alright. Okay. Energy increases. Electron is emitted from the surface. Residual kinetic energy. I should really learn how to read before going to quantum mechanics. Otherwise, the electron remains trapped in the potential well and is not emitted. Here we are assuming that the probability of an electron simultaneously absorbing two or more light quanta is negligibly small compared to the probability of it absorbing a single light quantum, as is indeed for the case for sufficiently low intensity illumination. Incidentally, we can calculate Planck's constant and the work function of the metal by simply plotting the kinetic energy of the emitted photoelectrons as function of the wave frequency, as shown in figure 1. A straight line slope. Okay, so being able to read this already. I'm just pretending most of the time, honestly. How is the progress in DSA? It's actually pretty good. We already went way further than I was expecting at the very beginning of the live stream. This is actually the end of the sub-chapter, so that's... If I understand this block of text, we're golden. We really are golden. Do I still keep saying photons? Damn it! I have to relearn how to read them. It's confusing. On one hand you have photons, on the other hand you have electrons. Too many of them, gosh, them particles. Physicists are just making stuff up. Atoms is an energy mostly because to enter a more stable state. Okay, hold on. Let me just... I need to digest this block of text. Then we are golden. Otherwise, the electrons remain non-potential. Okay, the first one is simple enough. The probability of electrons. Okay, second one is simple enough. We can calculate Planck's constant and the work function of the metal by simply plotting the kinetic energy of the emitted photoelectrons as function of the wave frequency, as shown in figure 1. So, calculate Planck's constant and the work function of the metal. So, basically, Planck's constant is a constant, but the work function of any metal varies depending on the metal. So if we want to figure out the work function of any metal, we can just plot the kinetic energy of the emitted photoelectrons as a function of the wave frequency. Make connection between EM waves and photons. Yeah, let me cook here for a second, right? I'm a slow learner. I'm a bit slow. Okay. So, if I'm understanding this correctly, function of wave frequency. This is wave frequency. This is K, so the kinetic energy electrons have when they are emitted. Yeah, alright. Then, so kinetic energy electrons have when they are emitted, and the frequency. Okay. Slowly running forward. Now, yeah, I can read characters. I'm pretty smart. What's next? By simply plotting the kinetic energy of the emitted photoelectrons as a function. Why is it W divided by H? It's W divided by H. Why is it this W divided by H? That doesn't make much sense. This is a new line. This is K. Why is this W divided by H? This plus a straight line whose slope is h, and whose intercept with the new axis is... Oh, intercept with the new axis. Okay, makes sense. Alright, okay, cool, sick. Oh, it clicked. So, this right here is just the K, kinetic energy based on the frequency. This point, not line, point right here is W divided by H. So the... Oh, it clicked so hard. Sick. What would be the slope of the line? It's H, so Planck's constant. Just the constant. Probably the most often used constant in quantum mechanics. Will it be only H? Apparently, yeah. Apparently, yes. Apparently, it will be only H. Simply pulling and function. Okay, the plot is a straight line whose slope is H. Obviously, H multiplied by nu, I'm assuming. Intercept with the new axis is W divided by H. Okay, so W divided by H. When W divided by... Right here, W divided by H. When nu is equal to W divided by H, what do we get? When nu is equal to W divided by H, then this is actually obvious, right? If we get if at this point nu is equal to W divided by H, which means if we solve this equation, we have H right here, which means we end up with a W, which means we end up with, not S, W, which means we end up W minus W, which means we end up with K is equal to 0. That's why it's equal to 0. Simple, right? Yes. Which means that if nu is equal to W divided by H, then the kinetic energy of the electron... Oh, I'm cooking right now. This is difficult stuff, right? Let me just... Is equal to 0. The function is a line. H is the slope of the line. Yes, H isn't changing. Yes, H isn't changing, but when you have a slope... hold on. Oh, I really do have quite a lot of cards. There's more... Like when you have a... I'm assuming what's happening is this. Right? You have H, which is a constant that defines the slope. Like, just like this, you can define the slope. So you have 1, 2, 10, let's say, then there we go. It's a constant, isn't changing, that's why the slope is always the same. Now... okay, cool, great, sick. Which means that if the frequency of a... was it photon, right? It was the frequency of a photon and emitted are electrons. Correct? If H nu, okay, nu is... Yes. Alex, listen, I love you. I just want to say, I am so glad you're here in the chat with us today. I'm... Like, normally this would take me an hour to get through. So, if I'm understanding this correctly, which at this point, I'm decently certain I am, if the frequency of the photon is equal to the walk... what's the name? Walk function of the metal divided by the Planck's constant. I misspelled Planck's. There we go. Planck's constant. Then the electrons are emitted. Well, no, they aren't emitted. But if it is larger, they are emitted with kinetic energy equal to H nu minus W. That's so easy. Will it be at the test? Yes, it will. They be... Wait, what? What are you letting me right now? But yeah, quantum mechanics. But the real quantum mechanics this time. Because I couldn't stress enough just how basic the quantum mechanics in the addition to quantum mechanics really were. That was extremely basic quantum mechanics. This is the more of a real thing. This is still the basics. There's just an introduction still, but we're getting there. This is sick, by the way. This is really sick. Photoelectric effect, by which a polished metal surface emits electrons when illuminated by visible and ultraviolet light. Hold on, because... Oh, this would be awesome for a video. Electrons emitted in small are called photoelectrons. This is gonna be awesome for a video. Because then I can... Oh yeah, this is great. Alright, I love it already. There we go, first of 4 chapters that I kind of had to... We might go through more chapters, honestly, if we're still gonna keep on going like we're going right now. Oh, this is gold. This is just straight up gold. Right here. When you publish the video about quantum mechanics, can't wait to see it. In 5 days, actually. You have 50,000 tabs open. It's research! I just have them open. I mean, on the other desktop, I have 2 different blenders open with satisfactory and I think around, I don't know, 40 other tabs. My PC is struggling. Okay, oh, this is gold though. This is just gold. I love it. Day 2 of asking how I'm not that smart. Oh god, there's another desktop. Yeah, I mean, that's where I keep my Blender renders. Did I mention that I'm actually rendering 2 different animations during this live? Yeah, I just might as well. What's the point of wasting time, alright? I have to upload a video in 5 days. Well, 6 days. My PC could never run that. I bought my PC to render 3D animation, so it better handle this. Actually, pretty funny story. I bought it from... imagine having 1,000 times to learn the basics. I am not that smart. I need them. Doesn't photoelectric effect Heisenberg uncertainty principle? I don't think it does. I'm pretty certain Heisenberg uncertainty principle is about position and momentum. I don't really see no position, no momentum. Oh, wait, no, frequency. Hold on. You know what? Don't listen to me. We'll get there. Once we get to the Heisenberg uncertainty principle, then I'll answer that question. Alright? I feel like, yeah. Let's take it one step at a time. According to Einstein's quantum theory of light, a monochromatic light wave of angular frequency omega propagating through a vacuum can be thought of as a stream of particles called photons of energy E is equal to h bar times omega. That's different from h nu minus w. Wait, no, is it? Oh, this is dumb. Hold on, this is dumb. This is dumb because nu is equal to 1 divided by t, but I'm pretty certain most of the time t is equal to 1 divided by omega. This is dumb. Why is quantum physics... Oh, come on. I just noticed you're VTubing right now. Oh yeah, I completely forgot I have a dance hat like this. We forgot about that one. Yeah. So V is... okay, this is nu. This is not V. That's important because this is V. This is nu. Omega is... yeah, that's why I said most of the time. And okay, not most of the time. I always like to use... hold on. I always like to use this notation. I've never seen anyone use this notation, but I always like to use it because, well, it's a kind of it's a very general sort of equation. Are you trying to learn or are you trying to answer viewer questions? Both. Thank you, Smith, for actually answering, yeah. I feel like this is a very solid kind of... because what this is basically saying is that you have the initial at... so t is equal to So t is equal to something at omega is equal to 1. Actually, this should be 1, not 0, right? I'm not crazy, am I? And then t0, that's basically what I'm saying. You need to pay attention where the 2 pi ends up. Yeah, so I should probably specify. Okay, so what we basically, so this is basically equal. So nu can also be thought of as, I like to generalize it with t0 because I don't know, in the future maybe 2 pi will be replaced by something and will catch me by surprise. I'll keep on. Okay, so t0, omega divided by t0, which means that right here this should be omega divided by t0. What's the difference between h bar? H bar is equal to h divided by t0. I knew it. So we can say that h bar would be equal to h divided by 2 pi, or in other words, in our case, no, it's always 2 pi. Okay, well, so, but I'll still note down as t0 because my dumb idiot brain will always wonder why is it 2 pi. Okay, so I can just 2 pi in this case. There we go. If you like it better. I will note this down. I guess this will be just a constant. I feel like, I mean, I'll probably also use that in the video because these sort of things are always confusing when you just have numbers. Well, if you're using letters everywhere, doesn't matter Greek or whatever, if you're using letters everywhere, then use letters. Don't use random numbers because it confuses people. And then also, if you're using functions, then remember to add brackets, because otherwise it also confuses people when there's just a freaking function, you know, now like this, with no input, by the way. You just don't have the function, then I'm angry. Okay, so t0 will be equal to 2 pi always. Doesn't have to be generalized, it's just a constant, it's just 2 pi. Nice to remember, which means h bar is also a constant, always equals to Planck's constant divided by 2 pi, which I'm gonna note down as h divided by 2,0 from t0, so remember why the 2 pi is in there, which means that E is equal to h nu is equal to h bar omega. But it is important to remember why this is h bar omega. Like, we're not just bringing the equations out of nowhere, no. This is still the same equality. It's just nu is equal to omega divided by, no, let's just expand it. If we're expanding it all the way, might as well. Divided by 2 pi. Cool. So h bar is sort of normalized in quotations. Okay, so with an asterisk attached, normalized Planck's constant. With an asterisk because all normalizations. But yeah, but that's kind of cool, sick. Which means right now we can figure out the energy of a monochromatic light wave based on the angular frequency. E should be equal to h omega 2 pi. E should be equal to h omega 2 pi. Yes. H omega divided by 2 pi. Right? Yeah, because nu is omega divided by 2 pi, so if you inserted this right here, you get h omega divided by 2 pi. But h bar is already divided by 2 pi, that's why only omega. It's not confusing at all. Simple stuff. Okay, where h bar, because classical light waves propagate at a fixed velocity c, it stands to reason that photons must also move at this velocity. According to Einstein's special theory of relativity, only massless particles can move at the speed of light in a vacuum. Hence, photons must be massless. That's why the momentum in the literally previous chapter was so funny. Wait, no, it wasn't previous. Not literally previous. Literally before previous chapter was so funny. According to Einstein's special theory of relativity, only massless particles, yeah, hence Photons must mass. Special relativity also gives the following relationship between the energy and momentum p of massless particle. Oh, never mind. Momentum right here. Cool. Loving your live streams. I'm really glad. I'm trying really hard every single day on a daily series of live stream checkups for which we're collecting money for charity. DBS Alliance, link in description or on the screen. https://makeit.app/make/reading God leads to my charity ink and the slice of pie for yourself. Link on the screen or the description. I have the impression there are a ton of formulas that mean the same thing. Yeah, most of them do. But it's, on one hand, many people may complain, but I think it's a good thing because it just... Okay, these formulas are there for a reason. They basically... So, for example, this right here is about the it's about the energy of a photon, but at the same time, you can also link it up to the constant velocity of photons. I should make a video on integrals. I technically have. I explain integrals in addition to quantum mechanics. There is an integral segment in there. Not a long one, but I don't think there should be too long of an explanation about integrals. Because if someone wants to if someone wants to actually solve equations with integrals, I'm not the right guy. I'm not the right guy for that. Okay. So, special relativity also gives the following relationship between energy E and the momentum P of a massless particle. Alright, let's keep going. I'm just noting down things wherever because it doesn't matter. For the video, I'll find them anyway. Anyway, e to the power of... Yeah, if you want to learn what quantum mechanics is. Yeah, it can be, that's the thing. Quantum mechanics, you have to remember, all fields of science are in the end made for scientists, not for people who are trying to get into science. So like it's understandable why they are so confusing, but I mean it's good for me, right? It gives me a job. That's why I can make YouTube videos, because there is a demand for simplifying science. I didn't even realize just how short this chapter was. Oh my goodness. Okay, well, so photons mass special relativity also gives the following relationship between energy E and the momentum of a massless particle. This is kind of okay. This sounds really silly on one hand. On the other, it makes sense. Momentum of a massless particle. Welcome to quantum mechanics. It's not confusing at all. I don't know why. I don't know why momentum of a massless particle makes me laugh so much. But now, previous relation is consistent with equation because if light is made up of a stream of photons for which E divided by P is equal to C, then the momentum density of light must be the energy density divided by C. Yeah, this. It follows from the previous two equations that photons carry momentum. So I will explain this equation now. P, also for myself I should mention, H bar K. Now, why the heck is this equal to this? Well, great question. I'm assuming it has actually a pretty simple answer. So right here we have, first of all, let's multiply both sides by C, in which case we'll get this, then C is equal to, where is it? I had light and then, there we go, omega divided by K. So C is equal to omega divided by K. That's all equal to energy. K's cancel each other out, and what we get in the end is, so K's cancel each other out, and what we get is, would you look at that? H bar omega. This is kind of the key point of the quantum mechanics. Momentum does not need mass. Yeah, I know. I love quantum mechanics, honestly, because of this. It's so cool. And it makes sense, actually. It makes a lot of sense that for momentum you need energy, not mass. It certainly does make sense. honestly, from it you only understand just how flawed classical mechanics is, not how crazy quantum mechanics, only how flawed classical mechanics would be. Because in classical mechanics, I'm pretty certain there is also a way to calculate momentum based on energy. But most of the time people use the mass because most of the time we're dealing with things that have mass. Direction of motion because omega divided by c is equal to k for a light wave. Oh, I could also use this equation, which would have been much faster. Oh well. Cool. So now, for light, we have momentum, we have energy. So rather, we have energy, we have momentum based on energy. Sick. You're a genius. We can find Alex. Yeah, Alex is... Alex is saving the live stream. Hold on. YouTube, stop my playlist. There we go. Let us now consider a classical interference of light waves. Figure F2 shows a standard double-slit interference experiment in which monochromatic plane... oh, damn it. And the sip for the... I can't do this. Shit's so bad. Drunk science. Oh, that's a great idea. Might do that in the future. Everyone will know this as everyone... I don't think so. I don't know if that's the case. There is a limit to what becomes standard knowledge, and I feel like internet is that limit. Don't drink and derive. Be responsible when integrating. Figure F2 shows a standard double-slit interference experiment, the most famous experiment in quantum mechanics, in which monochromatic plane light waves are normally incident on two arrow parallel slits that are situated a distance d apart. The light from two slits is projected onto a screen a distance d behind them, where d is much greater than d. That's much greater, right? I'm not misunderstanding. This isn't a different... This is much greater. Correct? I think so. I'm really hoping. So you have D, D. You know what? Actually, let's provide some input, because so far I'm only freebooting of a textbook, and I don't really like that. So instead, we'll actually set up this experiment ourselves. So we have... You know what? We'll actually do it with geometry nodes, because that's how cool we are. We'll actually set it up ourselves because we're smart and we don't need no help. So we'll have a plane. No, I meant... Oh, grid, sorry, it's called a grid. There we go. Which will be sizes, I don't know, 4 and 4. And then transform geometry. Move it up. Circuit and join. I'm almost done, don't worry. Boolean, not this kind of boolean. Boolean, mouth mesh boolean, this kind of boolean, and then this one goes down, and right here we want two slits. So how are you all doing, by the way? Now we have, now we have to wait for me to set everything up. How is your day? How are your days going? I can never figure out the Boolean and geometry nodes. Never make much sense. It's not difference. Intersect doesn't make much sense either. Union. No, it has to be difference. Oh, I forgot to select the cube. There we go. It's night here. Pre-accepted into new school. That's cool. That's great. Really happy for you. That's awesome. It's night. Yes. So it's. I have 4 exams this week. Oh, woof. What kinds of exams? to oof. I never did well any kinds of exams because I absolutely suck at doing things quickly. That's mostly what you need. And now, oh wait, now actually we can do the cool thing where we basically have combine XYZ and then combine XYZ and then this into muff. I said muff. This is probably unnecessary in the end, but oh well, I want it. Divide by 2. Then muff multiply -1. Just y? Yeah, this would y. Sec, and then the other one, which will be just... So actually we don't want to move this anywhere. We want it to be at the origin. I make it high and above, and I can do exams, but I can't study something that I don't like. Related, although I don't know, most of the things are very pleasant to study, it's just they're not really explained all that well. Most of the time I thought I didn't really like chemistry, or that I didn't like history, or other things like these. But then I, for example, started watching Oversimplified, or Many-Minute Man, or started actually reading actual well-written chemistry textbooks, and it worked out actually pretty well. Alright, there we go. This wrong value. This is the right value. There we go. So now we have the experiment set up. You might be asking, damn it, I keep pressing Ctrl S because I'm used to saving. Talking about science in this era and of TikTok and 30-second fame. School has a way of making interesting topics boring. I know. Also, they most of the time use very outdated kind of experiments. Yeah, this is taking ages to render, but that's only because I'm also rendering a lot of different stuff in the background. But the point is, double slit experiment. I have no idea how realistic. I don't think that's what it's supposed to look like. So yeah, there we go. I'm pretty certain. Oh wait, the distance should be much greater for this D. Yeah, I'm pretty certain that. Hold on, let's position it correctly too. I don't think that's what it's supposed to look like. So, well, now we know. I'm really glad I set the entire Blender file. It's all I know. I have to show off my skills whenever I can. 0.5 frames per second. Yeah, that's only because I'm rendering other stuff in the background, as I mentioned. Whoops. Consider some point on a screen that is located a distance y from the center line. So from here. Oh yeah, sorry, this is in 2 dimensions, I'm pretty certain too. Light from the first slit travels a distance x1 to get this point. This distance, whereas light from the second slit travels a slightly different distance, x2. It is easily demonstrated that delta x, x2 minus x1 is roughly d divided by dy. Let's try to demonstrate that. Roughly. Let's try to demonstrate that. I feel like the triangles begin. I'm not really that upset at triangles. A while back, damn it, make it, quit pressing Ctrl S. A while back, I did quite a fair bit of linear algebra trigonometry, a 3-dimensional trigonometry, and it was a pain. So I don't really want to repeat that experience. Alright, so what we basically have here is we're starting. You know what? Actually, I feel like there's a better way to do it. What would be the better way? Something like actually a curve would be much better. Yes. So we're starting at one of the slits, right? We're starting at one of the slits. So we're starting right here, for example. And then we get it to some sort of point. Hold on. And let's place like a sphere at that point. There we go. So this is where we want our thing to end up. Now we have the light traveling from the first one, and then we have the light traveling from the second one. This is our x1 and x2. Cool. This is our point, which was labeled some point. Okay, there's no some point. Cool. And then just rotate by 90, scale it down. I just want to make sure that I understand the thing before I actually get into learning some more about it. Alright, y. This is our distance, y. Now, if we take these 2 points, I mean these lines, what is the difference in their lengths? I feel like this would be actually easier to do in Paint, but okay. Here we have everything we need technically. Sick. And that's actually kind of it. We also have D, and we also have D. So let's try it actually. Right here we have a triangle with this distance and this distance. Now this point would have some. It's even worth doing actually. Is that a duck? What do you see? Where do you see a duck? What do you mean the D? Alright, so here we have a point. I don't know if P would be the right thing to label it. I don't know. Point smiley face, which is equal to some sort of X smiley face and Y smiley face. It's a duck with my. Where do you all see a duck? Am I going mad? Where do you see a duck? D at your. Oh, this one! Oh, I see it too now! Oh yeah, that's okay. I see it too now. Damn it, I can't unsee that now. Okay. Alright, anyhow, this right here is equal to, we have the first, so this will be our X and this will be our Y, which means this X wait, so this would be the position of the, so x1x minus xs is equal to this distance, so this distance. I'm trying to do it mathematically. I'm trying to contribute something actually instead of just reading a textbook live. Unless y'all don't want me to do all this math, then just let me know. I can skip it. This is T1, and right here we have the larger T2. And T2 in the exact same way would be equal to... actually, we can get the exact position of this based on D. That would be much easier. So x1x is just the negative D second. What is going on? Just doing some basic math. This should be negative. I should... There we go. Minus x of s. This, yeah. And then the second one, so x2. This is, oh, this is considering that this is, oh yeah, this is if the point is on the left. Or I guess it's not. Okay, so the first one is negative, for the second it's positive. Minus x of s. That's the first side. The other side is equal to d. So now let's get the length of the hypotenuse. So the length of x1 and x2. X, as we already know, this would be just equal to the square root of and insert the equation. X1 would be equal to square root of negative, this is the first side, so negative d divided by 2 minus xs squared plus d squared, and then this one would be equal to d second minus xs squared plus d squared. This is an awful time to run out of music, honestly, so let me just... Oh, I didn't loop the playlist, whoops. That's on me. I'm gonna just play a random one. Now, now let's solve it. This was a squared... Oh wait, this is with minus. Ah, I don't remember the equation for the minus one. A minus b squared gives you a minus b, which means it's a squared. Music is fire. I know, that's all made by Soda Guys, would recommend. Minus 2ab, right? Plus b squared. Because negative b times negative b is equal to positive b. A times negative b gives us negative ab. Negative b times a gives us negative ab. So yeah, a squared minus 2ab plus b squared. Cool. So now we just take these equations and we have x1, which is equal to a squared minus 2ab plus b squared. Alright, cool. So negative, this is d, so we have a root, first of all, very important, of d squared fourth minus 2, so d minus, oh, but this is all by itself has a negative sign. Wait, this is negative minus this. Oh, it's only making the problem worse. Does it? Is it making the problem worse? Minus, no. Okay. So, I think so. Hold on. Ah, my brain! What if both of them are negative? Well, then this one becomes positive, this one becomes negative 2ab. Take it down to positive. Oh yeah! I guess that I could do that. I could just take a negative out here, turn both of them into positive, and then... And square x, get that right? Negative square is positive. Okay, so I don't have to... Okay, cool. So that means d squared divided by 4 plus 2, so d xs plus xs squared plus d squared. All of that root. Why am I like this? And then this one actually has a negative. Yeah, so they are different. Because so this one actually has a negative, which means this one will have the thing. So this one would be d squared fourth minus 2d minus dxs plus xs. This feels wrong though. This feels really wrong though, because I'm pretty certain that this one will be smaller, which it clearly isn't. Something is off. Hold on, if we have negative 1 plus negative 2 square, then can I really... Wait, negative 1 minus 2 square, then this gives us 9, same as a 1 plus 2 square. Yeah. What's wrong? Wait, something is clearly off. x2 is larger than x1. It just is. It has to be larger than x1. And see it right here is just larger than x1. assuming d is the origin, by the way. Oh, this one's negative. This number is negative. Okay, makes sense then. Cool. Sick. That's why. So it really is larger. Sick. Cool. Fantastic. Lovely. Amazing. Can I simplify it somehow, by the way? I don't know. Wait, what was the end goal, by the way? Around d divided by d and y. Where's y? Oh yeah, y is the... Oh! The x, by the way, xs is just y. So xs is equal to... That's so confusing, though. Do you do streams at the same time? The timing is mostly random. Mostly when I have time. Okay, so xs is just y. xs is equal to... Well, negative y, I guess. Negative y in this case. Oh yeah, but we're doing it dependent on the... So y, let's just say y, whatever. Take the negative out of it and make it a positive. There's no point in making it positive, just... Wait, how to simplify this? Also, we're supposed to end up with d divided by capital D y. It is easily demonstrated that salutation needed. Provided that d is much smaller than capital D. Oh, this could be useful. Hold on. If d is much smaller than capital D, then this is the most important part of the root. Which means... I'm also an idiot, because we care about the difference of them. Oh yeah, right. So we care about x2 minus x1. We care about d squared fourth minus d xs, so basically minus y dy, plus y squared plus d squared minus d squared fourth plus dy plus y squared plus d squared. Simple. I mean... Yeah, you're doing great, thanks. Okay, the one thing which screws me over, so y is a negative quantity, is it? In this case, yes it is. I suppose, you know what, yeah, I did screw it up, because this shouldn't be, it should be absolute s is equal to y, which means absolute, alright, that's what it should be, which means right here we still need x. And I already know what's screwing me over, by the way. And what's screwing me over is the fact that plus dxs plus x squared s plus d. Enthusiast. Bro, it will take ages to solve. Yes, it will, but the reason why it's so annoying to solve is because right here it's not equal to. That's why it's so annoying to solve. So we have to assume that if d is d and d, then easily demonstrated that. I beg to differ. D divided by d. Wait, okay, hold on. Let's think about this graphically instead of just... Instead of whatever mess we just finished, right? Let's think about this graphically. What is d divided by d? Or rather, dy divided by d? Well... Do you know about the Taylor expansion of square? I am not doing that! No! We're not going down that route, alright? No way! We're not... No. 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 We're going the wrong way. We have to do it graphic. I am not doing a Taylor expansion. Okay, so let's think about this graphically. What is lowercase d? This ratio is the ratio between this and this, which means increase something that decreases, which means it's basically okay. Hold on, I'm an idiot. Yeah, it's the slope. I am an idiot. I know why I'm an idiot actually. Because this is actually much simpler than I am an idiot. Let's redraw this for a second just to get a clean plate. We have D, then we have D. Right here we have a center line, and right here we have Y. And right here we have a point, and this. So basically, hold on, let me just word it right. Approximate, simply approximate. Okay, yeah, that's because so no, I mean, okay, the Taylor expansion wouldn't take me that much time. It's just Taylor expansion would give us an exact value, and right here we're not going for the exact value. So it would be an incredibly difficult process to get an exact value. What we care about an approximation. So what d divided by d describes basically is just if we have d and d, then what d divided by d describes is just this slope. The slope basically. Yes, but you're trying it out of the first two terms because d is much larger than d. That's smart. But I want to do it the graphic way. I already did the graphic way. Okay, so d divided by d is just the slope in between d and d. I hate the fact that it's two d's. Okay, the Taylor expansion is actually really smart. You know what? You're better at mathematics than I am, because I didn't even think of that. But my point was that this is just the slope, and then you multiply it by y because it's the I know. Don't the Taylor thing. That would be a cool live stream though. Taylor expanding stuff. Perpendicular bisected point. This right here. Oh yeah, the difference between them. I'm an idiot. I keep thinking of a yeah. I keep thinking of just trying to figure out what these are equal to, but that's easy. It's the difference between them. Make a small triangle by the span slit and drawing perpendicular to 2x. Top slit and drawing perpendicular to 2x. Yeah. Oh! And then once you start, so basically you mean this way, kind of. And then this would be, wait, but then I have also one really dumb idea on how to do it. This really dumb one, like unbelievably dumb. It's kind of funny. Basically, I went from the slit to the 2x line. So from the slit, from the slit to the 2x line, as in to the middle of the 2x line, or this is the slit. So it makes a 90 degrees angle. Like this. I have one. I mean, yes. Okay, cool. I'm slow, as I mentioned, right? I'm slow. You have to explain like it to a 5-year-old, right? Did I mention that this is all optional what we're doing, by the way? We could just accept the fact that d divided by dy just approximates this. Also, another way we could do it is that we could just take this line, put it right here, and then we'll have the starting points, we'll have the ending points, and we're using a rotational matrix. We could rotate this line like this around the origin, and then we'll basically have where the point ends up, new coordinate, and then we'll basically have two coordinates, and this will be the exact difference between them. That's another idea on how we could do it, you know. I feel a bit stronger about this, honestly, because it's a bit easier to do. You just assume that this one is the origin, and that makes the whole thing really easy. The Blender way. I mean, not really the Blender way. I mean, okay, in Blender, you actually surprisingly, you don't have matrices in Blender. There are no matrices. It's so bizarre. Make it, quit saving stuff. Like, if I have a UV sphere, for example, if I go right here to geometry node editor, new nodes, matrix, there are no matrices. Nothing. There a vector math, maybe. Wait, are there any matrices vector math? I don't think there are. Is there... In what I mean by matrices, by the way, is that I'm pretty certain in Unreal you have a separate data type of matrices, just 4x4. In Blender, it's not a thing. For some reason, I don't know, no one cares about this. But this is, no, we could do it mathematically. This actually will be pretty simple. If you assume that this is the origin, right? Then, okay, first we have to assume that this is the, we have the origin. This would be simple, correct? Because then you have the starting point, you have the ending point, and you just shift it by d to the left. Which means if we have a system like this, right? Have d, and then right here in the middle of d, you have a starting line for y. Then y, right, like this, and then hold on, the y starts in, so we have to shift y to the left by 2d in order to actually, no wait, we don't have to. But this position, so take my word back, let's just accept the fact it is what it is. No, too late. We're doing this the make it way. Too late. I'm all in for it. We okay, so we basically have 4 points, right? We'll have first point and second point. We'll have first 0, first 1. We'll have 4 points. We'll have 4 points, alright? I don't even know the whole question. Doesn't matter, question is not important. Point 0, point 1, point 2, point 3. And then these would be equal to, respectively, x0, x, y0. Alex, you're more than welcome to the tail expansion in the meantime, because it's easy stuff. Well, it's easy to demonstrate that this is true. Yeah, yeah, I know it's easy to demonstrate. I'm gonna easily demonstrate it now. You should make a clear picture where every point and line segment is labeled. I don't need a clear picture. Clear pictures are for suckers. Yeah, I'm just gonna do it with cold, hard math. I'm not even gonna use the picture, alright? That's how good I am. So the 0, okay, I'm gonna label the points so I won't, you know, mistake them for That would be pretty silly. So we'll have these, right? Now, cool. Here's the thing. The starting, that's the initial position, the initial thing with the this and such, right? Cool, sick. We have 0, 1, 2, and 3. Now we might say make it. This is silly. Hi, I'm new here. Came from the addition quantum mechanics, physics video. Hi, welcome to live stream. How are you doing? How's the day going? It's what's I doing? Oh yeah, right. Now you may say make it. That's silly. The third and second point are in the exact same place. This is silly. Why would you do that? But yeah, it's a fair question. But that's because we're actually gonna move this entire line to the left. You see, by how much do we need to move it to the left? Well, that's simple. By d. You see, if we shifted d to the left, then 0 and 1 point will be in the same place, which basically means that these are our starting points, right? What's the issue? You have this drawing, right? And then we're trying to prove this. Oh, hold on. I'm covering the equation. Whoops, I didn't even notice. This is our picture, and this is what we're trying to prove. For fun. I'll give you all a second to screenshot if you'll wanna. Okay, but this is my solution to the problem. My incredibly sane and simple solution. What we basically do is we have all these starting positions, and then we modify them. So we end up with new points, and we shift these ones to the left. So we shift 1 and 3. So odd number points will be for the right one. We shift 1 and 3 d to the left, which means the new points, right? New points, so shifted points, will look like this. We'll have p0, which remains x0, y0. We'll have p1, which becomes x0, y0. We have p2, which was x2, xy2. And then we have p3, which becomes x2 plus d, y2 stays the same. This is still y2. Actually, y doesn't matter. Yeah, y is kind of silly because this is still y2. Was x equal to? I just created these values. It's not really. It's just the coordinates of these points. So these are the new ones, right? Now, I mean, if you want this, let me just open it up again. This is the original question. I'm just modifying stuff. So now, what we wanna do is wanna take this one. By the way, these ones are also 0, which means we can rewrite them as p0 is equal to 0, 0. p1 is equal to 0, 0. p2 is equal to x2 and d. And p3 is equal to x2 plus d and d. And now what we can do is we can use the rotation matrix. Alright, I'm gonna look it up this time because I ain't got the time to craft another one again. Two-dimensional rotation matrix. And also, we also need to figure out the angle between them. Pretty sure that's how it's derived by saying sine is equal to 10, x equal to x. And that's some of the problem became some. I think the rotation matrix is going right. There we go. Cosine, sine, negative sine, cosine. Now, also what we're gonna need is we're gonna figure out the angle in between these two, which will actually be unbelievably simple. Will it? Will it be unbelievably simple? Well, what's the position of x2? Great question. Position of x2, you see, it is the position of x2 is equal to y minus d2, d second. That's x2. Accept the fact. No, it's fine. It's fine. I can calculate this. It's simple. Okay, we already know that P0 and P1 carry over, so that's simple. Now, P2 is equal to it's y, right? Y. Oh yeah, we can go the other way, so we don't care. Minus the second. Yes. Y minus the second, and capital D, and P3 will be Y. Oh, that's interesting. We're getting some stuff done, because Y minus the second plus D, which means we can shorten this to get plus D second. D. Love determination. I am undertailing this. Okay. Cool. Great. Now all we have to do is two things. First of all, after we've both figured out this angle theta. Great. Which means that now what we basically have is this kind of thing. And for it, we want to figure out this angle theta, right? Which will be easy, actually, because we can take this angle and subtract from it this angle alpha. So this entire angle, I'm gonna call it lambda. How do you write down beta? I haven't wrote down beta in a while. I haven't done trigonometry in a while. Those were good times back when I didn't have to do any Hawking radiation. That's the wrong one. Oh damn it. This one, yeah. How do you write down beta? B. Makes sense. Now, beta. Cool. So, what we're basically saying is beta minus alpha is equal to theta. Right? So all we have to do right now is figure out beta and alpha, which is easy. It's simple. Why? Well, it's because we have this distance. We have all of those written down because we have the coordinates of this is P3, this is P2, all right? P3 and P2, and we have the coordinates. That's all we need. So, okay. So the angle first. Let's start with beta will be equal to arc tangent of arc tangent of opposite divided by adjacent, correct? Which means opposite, which is this one, so that's the height of P2, which is D of D divided by adjacent, which is this, so Y minus D2. Beta is the beta letter. Exactly, cool. Now, this is beta. Now, alpha is equal to arc tangent of the exact same thing except for this distance. So for P3, I mean, so Y, so D and Y plus D2. Which means that theta is equal to arc tangent of D. I love the music in the background too. It helps. Y minus D second minus arc tangent of D Y plus d second. Great. But you don't know d and d, do you? Yeah, that's the whole point. The whole point is to do it with unknowns. And because that way you can generalize stuff. Cool, so now that we know the angle, we know by how much we want to rotate it, right? So we know that this is by how much we want to rotate it, so we know that theta is equal to this. So now we can use the rotation matrix of cosine theta sine theta minus sine theta cosine theta. So we just have to plug all of these into this and there we go. Now there is a way to shorten these, I'm certain. I know there is a way to. Okay, so arc tangent with cosines and sines. What's the inverse trigonometric function? No, I mean like, how do they be canceling each other? Was that trigonometric identities? I think that's what it was called. Oh, the midlife 10 of my Firefox. Trigonometric identities. I'm getting more and more certain that you need to approximate something. I am fine. I don't need to approximate anything. List of trigonometric. There we go. We can make it happen. So, sine theta in relation to wait. There's what about arc stuff? Wait, we want arc. Hold on. Hold on. I need the inverse trigonometric. Right? Wait, hold on. Yeah, inverse trigonometric identities. Trigonometric functions, yes. Like, for example, how arctangent is equal to walk in kind of funny. Hold on. Is there really no such thing as inverse trigonometric identities? That's silly. Maybe there are. Okay, cool. So, yes. Arctangent is the one we have. And, oh, sick. Lovely. Now, what we're gonna do, actually, is a bit different. We're gonna get back to our document. And we're gonna scroll down to the very bottom. And we're gonna actually... call it mess, and in that mess we're gonna paste in this screenshot because that's, hold on, we're gonna paste in this screenshot as our cheat sheet, if you will. There we go. And now we'll basically have this. Cool. And now what we need is step by step, simple enough. So what we need is a matrix of 4 different. Can you even do matrices in equations? That'll be very convenient. Take down both sides. I'm doing it the make it way. You wouldn't care. Wait, is there no matrix relation? Unless I'm missing something. Alright. this. Arctan. So what we have is basically, let's give ourselves some space actually. Theta is equal to arctangent of dy minus d second minus arctangent of dy plus d second. Hi there, what's up? Hi. Yeah, I'm gonna. Yeah, it's the point. It's the idea. I'm trying to play. Hold on, it's cosine first. Bah. I'm gonna have just 4 of them. Okay, it's good enough. First, oh wait, I can't apply the identity because I have a big old minus right here. Well then, never mind. Screw it. Cosine of this, and then we have a negative sine of this, and then we have sine of this, and then we have a cosine of this, and there we go. That's the that's the rotational matrix we need to apply. Easy, right? Yeah. Which basically means our full vector will look like this. We'll have this there's no way bro just said, and there we go. And they're simple, right? We have this times x multiplied by this times y, or in other words, the what are the positions of our P3 that we're trying? X plus d2. Okay, x plus d2d. So x plus d2 is x. So we have this times x. So y plus d2, right? I'm mistaken. That's what it was. Okay, this is just a single cosine actually. Times y plus d second there we go, and that's added together with these plus this is simple stuff. I don't know what y'all complaining about. See, that's oh yeah, that's why I zoomed in right now, because I figured that could be the issue. There we go, and then all of these also have to be, but these have to be multiplied by d. And now we have the coordinates of the new vector, right? And so all we have to do so hypotenuse of the second point is equal to square root of this squared. I'm getting there, right? Alright, this squared. I'm having a mental breakdown. Plus this square. And so, let's make this a bit smaller, everyone can see. This is our this is our hypotenuse of the new thing, right? New point. Now the old one was y and y minus, right? This is minus. That's a minus, correct? That's okay. It's a minus. Cool. So the old one. So the hypotenuse of the first one is equal to square root of plus d squared, and right here we have y minus d second, correct? Am I right here? Minus, yeah, okay, cool. And now all we have to do is just take this line and Alex, listen, you wanted to do some silly Taylor expansion, you know, some silly stuff like this. There we go, that's your answer. That's the difference in lengths. That's what it's equal to. Already the Planck's one, because we're not doing this isn't quantum mechanics. I wanna be extra clear. This isn't quantum mechanics. This is just this is make it. There we go. Why would you now tell me and you know what? Be honest. When doing quantum mechanics, why would you ever use some sort of silly equation like this, right? Delta x2 minus x1 is equal to around d divided by dy, when you can just be exact and precise and use a solid equation. No. That's cool, that's great. Yeah, of course, right? So simple. I'm gonna make a video about this, by the way. Not about this thing alone, but I am kind of making a video about how equations get this large, and this would be actually a pretty solid example. It's like you already know. Yeah, it's like I didn't even have to calculate anything. It's, you know, it's actually pretty basic math. Like, you should be able to take a look at this picture and just think of this equation in your head. I would give you a value for each of these different coordinates, I mean for each of the different variables, but like we all can do it in our heads at this point, so we know. Oh boy. That's a make it live stream if I've ever seen one. Anyhow, back to the paper. Where were we? Oh yeah, right. Here. Cool. So, provided it follows the equation, well known that the fact that light waves are superposible, that the wave function at the point in question can be written... What is that character actually? This. I've never used that character before. I have seen it plenty of times. Proportional. Oh, I really should have used it more often actually. Proportion. Yeah, okay. Where a wave function at the first and second slits, respectively. However, first is equal to the second one. And then I was just accept the fact. No, we didn't accept it. What do you mean accept? There we go. We got the exact value. We've achieved progress. Necessary and useful progress. Anyhow. Because those lasers seem to be illuminated by in-phase light. Yeah, no, that ignoring difference. Yeah, the intensity, there's the energy flux of the light at some point projection screen is approximately equal to the energy density of the light, hence follows from the equation. The light density on the screen distance y from the center line is intensity of line distance y is proportional to the wave. This is cool, actually. Wait, hold on, this is really cool. What exactly are you making progress towards? I have no idea. Something for sure. I mean, there's no way I just wasted so much time, right? Okay, this is great. Because what basically is telling us is that intensity distance y away, don't highlight. Intensity distance y away is equal to the wave function of y and t absolute squared. And this equation should be already familiar to most people because this is basically the probability. What this is basically saying is that intensity at any point is proportional to the probability of that point ending up at that spot. Actually, no, that's wrong. The probability of any point falling onto this spot is proportional to this wave function. Absolute value squared. That's super possible, super possible that the wave function at the point in question can be written. I don't really follow this exactly. I don't know where this comes from. That's one thing. That's the thing where I'm lost. First and second. Oh, never mind. That's simple. Okay, so yeah, two cells seem to be eliminated by in-phase. Provided D is much greater than, yeah, it has to be. You do want, there's a typo there. If you want to be nitpicky, the I should be a function of T. Oh yes, that's actually, you know what? That's, I don't think it's a typo. I think it might be a mistake. Because if you want T in here, you should also input T at different times. Oh, but I guess that's why it's. I guess maybe they're saying that because it's proportional. No, it's still. I guess they're assuming time constant. That's why it's proportional. So you know, if you have constant time, if you're gonna change up y, this is still gonna be proportional. I guess that's what they are saying. No, I don't think you're wrong. I mean, if this was an equality, you would need time. Equation to obtain. So the intensity of light, wave functions at the first and second stage respectively. However, because two states seem to be eliminated in phase lighting, I'm trying to figure out where they got this. Because if I could find where they got this, then I could have an answer for a really cool question that most people have, which mainly is, okay, but why does the wave function absolute value square gives us this probability? The intensity that is an reflex of the light at some point on the projection screen is approximately equal to the energy density of the light at this point times the velocity of light. Hence, it follows from the equation, this one, 2,411, oh, never mind, no, wrong chapter, and that the light intensity at the screen distance 1 from the center line, 2,411, this one. So that's where they got it from. Because of this. Isn't this energy density? Well, you. Physics master student in Germany. That's cool. And also, yeah, you can. Always really cool have. Always feels really nice to have experts. Classical physics, light intensity is the square of the amplitude psi. So here we do the same. By the way, Alex, are you on my Discord server, perchance? nope. I would really recommend you join in, because I have a rank for experts that I just give to people who are better than me at certain things. And I would love to have a quantum mechanics expert, or a physics expert in general, actually. So if you'd like to become my physics expert to double check and triple check if I'm making any careless, silly mistakes in the videos, would recommend. And it's not would recommend, I'm mostly asking. Give me the link. All right, there we go. If any other damn it, give me a second. And if any of you would like to become an expert, then just let me know. But that is if you are an actual expert in the field. That is the requirement. That's Discord. To upgrade from media. Yeah, the expert is... Duh. I'm running out of water. And for example, Ali is also my expert. Studying medicine, my medical expert. Elliot is my expert when it comes to math, but I don't bug him all that often because qualification does become an expert. Basically, be significantly better than me. That's the requirement. If you're significantly better than me at something, if you're so much better at me than something that it is more convenient for me to ask you than to Google it, then there we go. There, you have an exclusive scientist rank. I'm assuming that Alex XKs you. Other people also suddenly join in. I have it linked on my Discord. No one checks my YouTube page. I have it linked there. Is Discord server only for experts? No, the Discord server is for everyone. There is a special rank and special chats for experts only. Oh no, you can see me asking Ali about medical stuff. Also, the advantage is that in the expert chat I really often post some snippets of videos that are required to, you know. Okay, there we go. Now you should have access to... Hold on, let me double check if you actually do have access, because I am an idiot after all. I do tend to get these things wrong. View server as a role. Intern booth, that's what it's called. So Ali, the intern booth, the expert only place. I'm just gonna type in the message, ping ya. That's what I do expect. And for all the other channels, we just tend to chat on Discord and all this stuff. So if you'd like to chat to me off stream, I answer on Discord almost always. If I don't answer, that means I'm either sleeping or in a hospital. So it's a 50-50. Alright. Wave maxima and minima satisfied. Hold on. Electrical and computer engineering student usually sits at the top 1% of the basics. I'm really good with embedded electronics chips and pretty much software hardware. That's the issue though. Software and hardware, for example, is my area of expertise too. So I very rarely make videos where I actually need to double check my knowledge because I just know most of these things. I'm really sorry about it. It's just, I know it's very annoying. I know it's a very annoying thing that I just happen to be an expert in this, but I mean, best example would be MKT multi-app, right? Or, okay, I suppose this is more of a software thing. It's really good that you are. Yeah, but it still is annoying when you know the thing that you're an expert. It just so happens that, I mean, you can still join us in the chat. I mostly just I just need experts to not make any silly mistakes in my videos, because it's much harder to fix a mistake than to not make one. I'm certain there's some sort of catchy quote there. Okay, hold on. This. Great. is equal to cosine, or which is around equal to this. Shows the character interference pattern corresponding to the previous expression that consists of equally spaced light and dark bands of characters with delta y is equal to d lambda divided by d. So delta y would be, wait, is that the wavelength? Why is this there? Oh, it's because this is the interference pattern after 2 slits. What's the progress so far? It's actually a lot of progress. We did a lot of progress today. So if I'm understanding this correctly, delta y would be the new wavelength. Correct? Wait, that doesn't make much sense though. No, it does make sense. This is just not a wavelength of a wave that is traveling, it's just on the wall. So this is the wall, basically, because this is just the function of y, and y is just the distance of the wall. Yeah. So this would be the wall, and this would be just the intensity of light, just so how bright each thing is on the wall. Okay, cool. So delta y, which is the distance between the darkest spot and another darkest spot, is equal to d divided by d lambda. I know what, I'm gonna write this down. Double slit experiment. This is gonna be a very difficult thing to animate, I've gotta say, because Blender isn't simulating light that realistically. So, you know, this, I'm gonna have to do it. I'm gonna have to implement more realistic. Actually, no, I'm not gonna implement more realistic light rendering. That'll be. There's no way I can do that in 5 days. But I'm gonna have to manually set up renders based on the end result. So that's gonna be fun. But this is great. This is basically the double slit, the simplest kind of double slit experiment explained, which means that we can calculate the distance in between the darkest spot when we have these 2 slits. Different engines. Different engines actually showed slit in. There is no way. That's insane. D. Oh, this is gonna be fun as heck. I mean, the way I'll probably do it is. No, let me actually show you how I'll probably do it. Right now we have geometry nodes, right? Correct? Right here. We have. Let me turn off all of these messes. Unnecessary. Sick. I'm gonna delete the light. And right here, I'm gonna set up. Actually, I might do it live. Turned off. Don't render. I think it's too late. I think I broke him. Blender gave up. Oh, I didn't save. I didn't save because I wanted to do it live on stream. Damn it! I mean, I can implement. It's not that difficult to implement. Because I do have literally an equation which is telling me how to implement it, but... using this equation right here will be unbelievably easy to implement this. Blender tired, Blender sleep now. Blender ain't getting no sleep until I say that can get some sleep. Blender ain't crashing unless I say so. Hold on, let me check something real quick. You wanna see a sneak peek? Video. Let me show you what's happening on my other desktop, by the way. This is what I'm also rendering in the background. Each frame takes 2 minutes, not because this is a complex frame to render, only because... Where's motion blur? There's supposed to be motion blur. There's no motion blur, damn it. Sucks. Is it nice to buy your Be Back Soon screen? Kind of, yeah, kind of. I mean, it's nicer than just black screen, right? It looks pretty sweet. It's a nice little render. Very simple one, but still, looks neat. Damn it. Fine. My point is, it's very easy to implement. Okay, what's the last chapter we're supposed to go through today? Telling us. It's very short. Okay, great. Because the double-slit inference from a quantum mechanical point of view. According to quantum theory, light waves consist of assuming massless photons moving at the speed of light. Hence, we can split this little figure. We spraying photons in all directions at the same rate. Suppose, however, that we reduce the intensity of light source illuminating the slits, so we get only a single photon is present between the slit and projection screen at any given time. Place the projection screen by a photographic film that records the position of one sufficiently long time. The many protons have passed through the slits. When graphing we develop film, we see an interference pattern which looks like shown in figure. The answer to this question, as demonstrated in the experiment, is what we see exactly in the same interference pattern. According to previous discussion, you're not streaming on Twitch? No, I'm not. I'm not streaming. When I'm doing science streams, I don't stream on Twitch. When I'm streaming gaming streams, I stream on Twitch. According to the previous discussion, the interference pattern is built up one photon at a time. In other words, the pattern is not due to the interaction of different photons. Moreover, the point at which a given photon strikes the film is not influenced by the point at which previous photons struck the film, given that there is only one photon in the apparatus at a given time. Hence, the only way in which the classical interference pattern can be reconstructed after great many photons have passed through the apparatus is if each photon has a greater probability of striking film at points where the classical interference pattern is bright and lesser probability striking the film at where the interference pattern is dark. Cool. Suppose that then we allow n photons to pass through the apparatus and we count the number of photons that strike the recording film between y and y plus delta. Or in other words, we just y plus delta basically means, hold on, let me just resize this a bit. 7, it means in between the dark spots or in between the bright spots. It basically means, you know, just like one cycle. That's from y to y plus delta. Where delta y is a relatively small division. Let us call this number ny. The number of photons that strike a region of the film in a given time interval is equivalent to the intensity of light illuminating that region of the film multiplied by the area of the region, because each photon carries a fixed amount of energy. Hence, in order to reconcile the classical and quantum viewpoints, we need... Okay, this is intensity, which correlates to intensity multiplied by delta y. This is a... So we have a function which is equal to the limit of, as n approaches infinity, ny n. What's ny? Call this number ny. This is the number of photons that strike the recording film between y and okay. But why do we... Is ny dependent on the... It has to be dependent on the this n, right? Because otherwise it's just gonna spike off to 0. Probability that given the photon strikes the film between y and y plus delta y. Know that py correlates, not correlates, what's the word? I forgot the word, but you all get the idea. It's proportional to delta y. In other words, the probability of photons striking a region of the film of width delta y is directly proportional to this width. Makes sense. Larger the width, higher the probability. Alright. Actually, this is only true as long as delta y is relatively small. It is convenient to define a probability density, py, which is such that the probability of photons striking a region of the film of width dy is py is equal to py of y is equal to p of y dy. Now, equation 281, this one, yields py of y is proportional to I of y dy, which gives p of y proportional to I of y. However, according to equation 274, I of y is proportional to psi of y t absolute squared. Thus, we obtain that the probability of photon striking each place is equal to the probability density of photon striking a given point on the film is proportional to the modulus squared of the wave function at a point. Another way of saying this is that the probability of measurement of photons distance from the center line at the location of film yielding a result between y and y plus dy is proportional to psi of yt absolute value squared dy, which makes sense. This is the big connection between particles and waves. I can tell right now, and this is sick. Oh, it makes sense. Okay, this is great. This is amazing. This is neat. This is horrible live stream material, by the way, because it's basically just me reading text. But it is important. Know that in the quantum mechanical picture, we can only predict the probability that given photon strikes a given point on the film. If photons behave classically, then we would in principle solve the equation of motion and predict exactly where each photon was going to strike the film, given its initial position and velocity. This loss of determinacy in quantum mechanics is a direct consequence of wave-particle duality. In other words, we can only reconcile the wave-like and particle-like properties of light in a statistical sense. It is impossible to reconcile them on an individual particle level, which means we can only treat particles with probability. We can't treat them in classical, like we treat objects in classical mechanics, with just a value as in with different values. We need functions describing probability of these values because it's a wave-particle duality. In principle, each photon that passes through an apparatus is equally likely to pass through one or two slits. How to leave? What has happened? We're making breakthroughs. Can we determine through which slit a given photon passed? Suppose that our original interference experiment involves sending n, which is way smaller than 1, photons through our apparatus. We know that we get an interference pattern in this experiment. Suppose that we perform a modified interference experiment in which we close off one slit, send n divided by 2 photons is through the apparatus, and open the slit and close the other slit. The n divided by 2 photons through an apparatus. In this second experiment, which is virtually identical to the first on the individual photon level, we know exactly which slit each photon passed through. However, the wave theory of light, in which we expect to agree with the quantum theory in the limit n, which is way greater than 1. I have to go my back. I have to go to oh no, okay, I'm gonna end the live stream soon too. So I just want to get through this. Once I get through this is the link between particles as waves and waves as particles. Wave-particle duality. Once I get through this, I'm also gonna end the live stream. Bye, Alex. You've carried this entire live stream on your back, and I really thank you for it. Each photon passes through apparatus likely passes through one of the slits. We can determine through which slit given photon passes. Suppose the origin involves sending n much greater than 1 photon through our apparatus. We know that we can get an interference pattern in this experiment. Suppose we modify in which we close off one slit, send n divided by 2 photons through the apparatus, and then open the slit and close off the other slit. We send n divided by 2 photons through apparatus. In the second experiment, which is virtually identical to the first, so basically what we're doing is right here we're sending some number of photons through these slits. Right here we're sending half this photon through the first one and half through the second one. Second experiment, which is virtually identical to the first, on the individual photon level, we know exactly which slit each photon passed through. However, the wave theory of light, which we expect to agree with the quantum theory in the limit n much greater than 1, tells us that our modified interference experiment will not result in the formation of an interference pattern. After all, according to the conventional wave theory, it is impossible to obtain a 2-slit interference pattern from a single slit. Hence, we conclude that any attempt to measure through which slit each photon has passed in our 2-slit interference experiment results in the destruction of the interference pattern. It follows that in the quantum mechanical version of the 2-slit interference experiment, we must think of each photon as essentially passing through both slits simultaneously, which is massive. I'll have to reread this off stream because this doesn't make for good stream material, just reading like that. But for now, I suppose we did a lot. We did crazy lot. We basically got through all of light, which is massive. The next one is particles, so it's also gonna be kind of cool. So that's great. I'm gonna go now, work on some more animations for the video, script more of the video. We learned we did indeed learn wave-particle duality. I'm gonna go make some animations for the video, script the video, rest with Theft on Satisfactory, which I'm also probably gonna stream. Well, not probably gonna stream. If I'm gonna do the Satisfactory with Theft, then I'm definitely gonna stream. And for now, that'll be it. For now, I suppose that'll be it. Thank you everyone so much for watching, and have a great day. Bye.